Hello, this is Matt Gaskill, Philosophy 160, presenting problem 6.8.G7. In this problem, we're supposed to take the first 6 premises, G6 and G1 through G6, and prove that G7 follows from those premises. And then we're given a hint to use the new name for the negated G7 to instantiate G1, G3, G5, and G4. So the first step is to write down the negated G7, which is what we've got, the negated universal X, G X fx equals G fx x. And the hint tells us to use the new name from the negated G7 to instantiate G1 through G4. So the first thing we need to do is instantiate a new name. Now we can see in the premises that we already have a name A instantiated. And so the next name for us to instantiate will be a B. So we take the negated universal X and we can move that negation to the right of the universal, which then turns that universal into an existential. So using existential negated G of X of X fx equals G fx, we end up with G B fb not equals 2, so the negated equals G fb b. And now, after instantiating the new name, we called it B, let's go ahead and we follow the hint and instantiate a G1. And so using G1 here, we've got the universals X, Y, and Z. Gx, we'll use our B, and then we see in line 2 that we have an FB as well. So we'll go ahead and use FB. We'll give it a try using FB for Y. And for Z, we'll just do another F of FB. And so we end up with the line 3 that we have here. Continuing on with the hint, it suggests to utilize G3. And so G3 here is universal X, Gx fx. So we'll just use the B and the FB since we have that sequence, that kind of chunk of data here in the right side of line 3. So you might ask, well, why did you choose B FB? Why not FB FFB? And it's a good point. So we'll go ahead and instantiate a G3 in that pattern as well. And then we can see here that according to lines 4 and 5, they both equal A, which then means that since A equals itself, that the left side of each of those sentences equals each other. So we'll go ahead and set up a line 6 using lines 4 and 5 and just equating GBFB equals GFB FFB because A equals A. We'll then go ahead and take line 3, and I've color-coded them so we can replace the green text with an A. So this becomes GB and then A, which is what we got here on the left side of the equal sign. And then the right text also changes to an A at AFFB. And so we end up with line 7 here, which is just swapping out the equivalent chunks of text there. And then continuing on, we've utilized G1, a couple of G3s. So the next hint is to use a G5. And so here we use G5, which is going to be an X of some sort, and then A, and then we have an A X. So we kind of swap those two. And what we're trying to do ultimately is we have this GBFB is not equal to GFBB. So what we're thinking is if we can set up a line all by itself that says that the left and the right side of this are equal, then we will have our contradiction and be able to close the tree, showing that the conclusion is valid. So that's our goal, really, is we're trying to get these to show that these left and the right of this sentence are in fact equal, so we can have a contradiction. So we're kind of trying to move toward that. So we have this AFFB sitting in here on line 7. So that kind of gives us a hint as to where we might want to go. So one way to try it is to instantiate G5 by setting it to A and setting our X equal to FFB. So that's what we did here with line 8. And then the last hint we have is a G4. G4, it's kind of wide open here. It's universal X, Y, and Z. And you can set up your G with an XZ, and then you end up with this long string. And so again, we're trying to do is select X's and Z's and Y's to try to move us toward this line 2, setting up a situation where we can show that this line is actually equal. So we end up with line 4, which is setting X equal to FFB, Z equal to A, and Y equal to B. And then that ends up in this line here that we've got, this material consequent line. And so we need to do a little bit of work here. We can take lines 8 and 9, and we've got this GFFB appearing in both lines. And so we're going to go ahead and just swap out the right sides and make those two right sides equal. So we've got GAFFB equals the GBA only if FFB equals B. So we're just swapping out equivalent chunks. They're equivalent because that line tells us they are. And then leveraging line 7, finally, we have that GAFFB that we saw earlier. And that's why we instantiated line 8 the way we did, was so we'd have this equality. And so what we're going to do is we're going to take that GAFFB that we have in line 10, and since according to line 7 it's equal to GBA, we're going to go ahead and just replace it. So we get GBA equals GBA only if FFB equals B. So we go ahead and we can now branch this material consequent. And so we take the negated antecedent, which then says GBA is not equal to itself, which is a contradiction. So that closes that branch. And then we've got FFB equals B. Well, if FFB equals B, then I can go back up into previous lines, and wherever I see FFB, I can replace it with B, or vice versa. Wherever I see B, I can replace it with FFB. So what I chose to do was go to line 6, where I've got this GBFB, and I take that line, GBFB as it is, equals, and then I've got this FB, FFB, and I just replace this second item here with FFB with a B, and I've got GFBB, and I'm showing that they're in fact equal. And that's a contradiction to line 2. It's a direct contradiction. And so that's what I was going for all along, was to contradict that line 2, which we've done here on line 13. So between lines 2 and 13, we've got a contradiction. We close that branch. All branches are closed. Therefore, the conclusion is valid. All right. If you've got any questions, hit me out on the pronto. Thanks.